Alright, hello, welcome back to my YouTube channel. Today we're going to be looking at the quadratic formula and deriving it in a new way that I just found. It's the easy way. The easy way. It's not really that easy. It's pretty unintuitive, but it's once you figure out the trick though, it actually is intuitive, which is pretty interesting. So let's go ahead and take a look without further ado. So the first step of the derivation is to start with the general second order polynomial. Just like when you complete the square, that is ax squared plus bx plus c equals 0. And of course, a is not equal to 0 because if it were, it would not be a polynomial, or sorry, it would be a polynomial. It would not be a quadratic. It would be a linear equation. And that's pretty easy to solve. So the next step is you multiply both sides by 4a and you distribute the 4a into the equation. So here we have the algebra. You can see that 4a times 0 on the right-hand side of the equation is just 0. So I went ahead and just did the math and distributed it out and just left the right-hand side equal to 0. The next step is to add b squared to both sides. Why b squared? You'll see in a minute. It seems like a pretty arbitrary thing to add. Why would you multiply by 4a? Why would you add b squared? It works. It's just because that's the way it works. So as you can see, we just add b squared to both sides. Obviously, you can just subtract them and they'd cancel out, but we don't want them to cancel out. We want to use it. We want to use that to our advantage later. The next step is to subtract 4ac from both sides. So now the right-hand side is b squared minus 4ac. Does that look familiar? It looks familiar to me. That's going to end up in the final version of the quadratic formula. And we've got this left-hand side, which is just this mess. But we're going to see that this actually isn't a mess. It's actually a very neatly packaged left-hand side. So let's go ahead and see. Step 5 is the hardest step of the equation, provided that you've already thought of the adding b squared and multiplying by 4a part. But it's to factor the left-hand side. Now, this is true. We can verify this by multiplying this binomial out, or multiplying this quadratic out, I guess, by doing FOIL. So 2ax times 2ax, well, that's 4a squared x squared. Okay, good. 2ax times b, that's 2abx. Well, then you have to do it twice, so that's 4abx. That's what we have here in the middle term. And then b squared, well, it's just b squared. So yeah, you have it right. And then we don't do anything to the right-hand side on this part. It just stays the same. So that's the hard part. But once you get that done, the rest is easy. You just solve for x, turn the algebra crank. This is stuff you can do pretty easily if you just know a little bit of algebra. You just take the square root. Don't forget the plus or minus. I put that in red there just to make sure you don't forget it. But after that, you just subtract b, divide by 2a, and there you go. You've got the quadratic formula. So this is 9 steps of algebra compared to when you complete the square. It's like, I don't know, maybe like 20 lines, maybe even more. It's been a while since I've done that. I don't know the exact number of lines you need, but it's more than this for sure. But let's take a look at some interesting things. So a few questions, like why would anybody think to multiply by 4a and then to add b squared? That doesn't make sense. It's a very unintuitive thing. Why would somebody do that? And also, how come it was so short? Like completing this, how come nobody taught me this? It really is what the question should be. Is like, how come I wasn't taught this in high school? How come I was taught the completing the square method? And like, sure, that's a cool method. I enjoyed learning that, but this one is way faster. And well, the truth is that there's a secret I'm not telling you yet, and let's go ahead and take a look at it. The secret is that I actually didn't think to add and multiply those seemingly arbitrary quantities, right? What I did instead, like first I didn't even derive the quadratic formula, like from starting from the polynomial, moving to the quadratic formula. I didn't do that. Like I did, but not in a really direct way. What I did was I actually started from the quadratic formula being fully formed, and then what I did was derive the polynomial equation. So I actually did it in reverse and then just switched the order at the end. And so let's go ahead and take a closer look at this. So algebra works both ways, and in this case, going from the polynomial equation to the quadratic equation is really difficult. But going from the quadratic equation to the polynomial equation is actually really easy. So let's take a closer look. So this is a lot of math, and good thing my camera is not blocking the math. So the left-hand side is what we just did. The exact same thing. I just copied and pasted the equations. The right-hand side is literally the exact same thing as the left-hand side, but I just flipped things around and made some minor adjustments. Like I put this a equals 0 in the first line here, that isn't on this line. And I also took out this, on the second line of the left-hand side, there's a 4a times 0. I just took that out on the right-hand side. So let's take a look. Well, on the left-hand side, well, you multiply by 4a, add b squared, factor it out, and solve for the formula. On the right-hand side, it's very easy, very intuitive. Just do what feels natural, in my opinion. Like if you've done algebra a long time, just do what feels natural. That is, multiply by 2a. Okay, there's a fraction. Get rid of the fraction. Multiply by 2a. Okay, well now I've got this minus b. Let's get that here. I don't like minus signs. Let's make everything positive. So that's 2ax plus b. Okay, well now this is annoying square root here. This plus or minus square root. Okay, let's square both sides. So now 2ax squared plus b, or sorry, 2ax plus b squared is equal to b squared minus 4ac. Okay, well I don't like that 2ax plus b squared. Why don't we just FOIL that out and distribute the polynomial? Okay, we do that. That's pretty ugly. Let's cancel out what we can cancel out. Those b squareds cancel out really nicely. Let's make things neat first. Okay, then cancel out the b squareds. Okay, we've got the right hand side now equal to 0. Hey, wait a minute. Every term in this left-hand side now has a 4a in it. Let's pull that out. Okay, look, I've got ax squared plus bx plus c, and that's times 4a equals 0. But wait a minute, we know that a is not equal to 0, and so we can just divide by 4a, and then we just literally get the polynomial equation. So multiplying by 4a, as clever as it might look, and I didn't come up with this method, by the way, I found this on the internet. As clever as it might look, really isn't that clever if you just do it in reverse. If you just go from the right side and just start from the bottom and go to the top, you literally just derive the quadratic formula. So the truth is, the lesson here is that mathematics, especially algebra, works both ways. But sometimes one way is easier than the other. So if you're trying to prove something and you have a suspicion that something might be true, but you can't quite prove it, why don't you start from the statement that you're trying to prove and try to whittle that down into something that's true? Because it might be easier to go from the top down to the bottom than it is to go from the bottom to the top. So I thought that was pretty interesting. Thank you very much. Goodbye.